This is part 2 of the homework video guide, and for question number 6 I have another arithmetic sequence, and for this sequence the first term is going to be negative 21, the second term is going to be negative 6. And for part A I need to find the common difference, so the common difference can be calculated as the second term minus the first term. Okay, as mentioned, the second term is going to be negative 6, and then the first term is going to be negative 21. And since we have two negative signs, so we can change that into a positive sign, so negative 6 plus 21, and that's going to be equal to 15 as your common difference. Okay. For part B, I need to find term 5. Okay, so we have negative 21, negative 6, we have 9, we have 24, and from 24 we're just going to add another 15, and we should get 39 for our fifth term here. So this right here is going to be our fifth term. Okay, now let's move on to question C here, and for question C I need to find term 90. So once we get to these bigger terms here, we can start using our formula for arithmetic sequences, which is Tn, which is T1 plus n minus 1 times the common difference. So we know that this n is connected to that n right there. So I have term, and then I have term 90 here. So from that we know the n value is going to be, this n value here is also going to be 90. Okay, so now we need to have my first term, and from our first sequence here we know our first term is going to be negative 21. So this will be, I'll put this in red here, so negative 21 plus bracket 90 minus 1, and then our common difference was 15 as calculated in part A. Okay, so now we can just do some more calculations here. So this is negative 21 plus, and this would be 89 times 15. And then from here you can go to your calculator and calculate 89 times 15. It's going to be a pretty big number in here, so 1,335. And then if we subtract the 21 from that, we can get our final answer, which is 1,314, which is term 90. Okay, let's move on to letter D now. Which term has a value of negative 471? Okay, so basically, if we go back to this little sketch right here, if we keep on going here, eventually there's going to be a certain term that's going to have a value of negative 471, and we've got to figure out which term value this is. Okay, so maybe it's the 10th term, maybe it's the 100th term, but we need to figure that out. Okay, so for that particular question, we can start off by using our formula, which is Tn equals to T1 plus n minus 1 times the common difference of D. Okay, so what we can do here is we know that the term value has a value of negative 471, and we can set that equal to our Tn. Alright, so we can kind of consider this maybe the last term in the sequence by making this negative 471. And then we make this equal to the first term, and as mentioned, the first term is negative 21. Plus, okay, so we know the term, we know that this Tn and this n right here, they're connected there. So if we have a Tn value of negative 471, we can definitely find where that is in the sequence, the term value there. And our common difference here is going to be 15. Okay. Alright, so from here on, let's go ahead and solve this. We can start off this by, we have a negative 21 here, so we can add the 21. So adding the 21 there. So more calculations that you have to do here. So 471. So now we have negative 450 here equals to n minus 1 times the 15. And instead of distributing the 15, I just recommend that you divide by 15 here. Let's divide that by 15 and divide that by 15. So those will cancel off. And 450 divided by 15 is going to give you a value of 30. So it's going to be negative 30 equals to bracket, now we have n minus 1. And then if we go ahead and just add the n here, we have a negative 30 plus 1, which is going to be negative 29. Okay, so if I just go back to this part right here, what we're saying here is it's that the 29th term right here is the 29th term that has a value of negative 471. All right, so these are some good questions right there. So it's a good mix of arithmetic sequence problems. Question number 7 here, find the number of terms in the arithmetic sequence. Okay, this is another great question. So in this problem here, our first term is going to be 3, our second term is going to be negative 1, and then we have a bunch of other terms, and then we know our last term here, our last term has a value of negative 117. So we're going to figure out how many total terms are there in this sequence. Okay. And we can actually get this question right from the formula. This is very similar to the previous problems here. So if we go ahead and just write out our arithmetic sequence formula here, we can just plug the numbers into this. So this Tn is kind of like your last term here, right? So the last term here has a value of negative 117. And if we know the last term is 117, we know that this term is connected to this value of n there, so we can find out the total number of terms in this sequence. All right, so the first term here is going to be 3 plus n minus 1. And now we need to find our common difference, and our common difference we can always find by taking our second term and subtracting our first term. Our second term is negative 1, and then we can subtract our first term and we get a value of negative 4. And that's pretty easy to identify here, right? So we know we're going down by negative 4 each time. All right, and there you are. All you have to do now is now find the value of n there. I would go ahead and attack the 3 first. So if there's positive 3, we can subtract 3 from both sides. If I subtract 3 from both sides, I get negative 120 over here on the left-hand side equals to n minus 1 times negative 4. And instead of distributing, just divide each side by negative 4. Okay, and we know the negative 4s will cancel. I have n minus 1 on the right-hand side, and 120 divided by 4 gives you 30. If I add 1 to both sides, I get 31 total terms in this sequence. Okay, so going back to my diagram here, I know 117. This is actually has the value of, this will be term 31. Okay, so there's 31 terms in the sequence. Okay, let's keep on going, and let's go through a few more of these arithmetic sequences here. Determine the 4th, 5th, 6th, and 7th terms of this arithmetic sequence where we're given term 3 and term 8. So if you want, you can go ahead and just kind of sketch out this problem here. We know for my third term here that has a value of negative 24. The 4th term, the 5th term, the 6th term, the 7th term, and then we have the 8th term over here, I believe. And that has a value of negative 94. Okay, perfect. Okay, there's definitely a few ways you can think about this particular problem, but for this problem I'm going to take a different approach here. And what I'm going to do with this particular problem is I'm just going to focus on this part of the problem here, and I'm just going to relabel things. So I'll call this term 1 now. I'll call this term 2, this is term 3, this is term 4, this is term 5, and this is term 6. So by doing that, I know there are a total of 6 terms in this sequence. And I know my first term now is going to be negative 24. Okay, and I also know my last term, which is term 6 in this case, which is negative 94. I can label that as Tn equals to negative 94. Okay, so I'm just going to take a different approach to this particular problem here. There's different ways that we can approach this problem from the first spiral, but I want to kind of work with the formula for this particular problem here. And if I use my formula over here, I can now actually find my common difference, which is d, right? So I know my Tn value, as indicated, is going to be negative 94, my last term, equals to my first term, which is going to be negative 24 now. And then I'm going to add my n minus 1, and my value of n, we know that the value of n in this case, there's going to be 6 terms now, so this will be 6 minus 1, and then I can multiply by my common difference d. Okay, let's go ahead and do the math here. So I have negative 94 here, equals to negative 24 plus 5d, and then I can add 24 to both sides. And more calculator work here. So let's go ahead and compute that. This should be a negative 70 here, equals to 5d. Divide both sides by 5. And if I divide both sides by 5, I get a value of negative 14. Okay, so it looks like we're subtracting by 14 in the sequence here, right? So now if I go back to my sequence now, we know my common difference here is negative 14. And we're going to subtract 14 each time now. So my next value will be negative 38. If I subtract another 14, I get negative 52. And then if I subtract another 14, I get negative 66. And then if I subtract another 14, I should get negative 80. And then I get negative 94 there. So there is now, if I go back to my original problem now, I guess this will be my term 4, term 5, term 6, and term 7. Okay, so that's another way that you can kind of approach that question by using the formula. Are there other ways that you can find the common difference by looking at the number of jumps? Absolutely, but I just wanted to show you the way that you can approach this using the formula method, and you'll get the same answer regardless. Okay, so move on to the last kind of question in this homework video guide. For question number 9, now we have these polynomial expressions here, x plus 1, x plus 5, and 3x plus 1. There are 3 terms in arithmetic sequence here. And we need to find the value of x that will satisfy this arithmetic sequence here. So we know, let's just label this as my first term, my second term, and my third term. Okay. So in order to do this kind of problem here, we need to understand that the common difference is really your second term minus your first term. But we can also find our common difference by taking our third term and subtracting our second term. Okay. And what we're going to do is we're going to make the common difference equal to each other for these two equations. So we're going to make this value of d equal to that value of d. Okay, and if I do that, let's go ahead and find our t2 value. So our t2 value is x plus 5. So I'll put this in a bracket. Actually, I will make this in a bracket of x plus 5, and then I'll subtract my first term, which is x plus 1. And then for my common difference over here, my term 3 is going to be 3x plus 1 minus my second term, which is x plus 5. Okay, so essentially we're going to kind of make our common differences equal to each other. So if I do that, we have all of this, which is x plus 5 minus x plus 1. Oops. A little bit more space here. And then I have my common difference over here, which is going to be 3x plus 1 minus x plus 5. And then from here, we need to solve this, this equation here, and this should look very familiar to one of the homework problems that we approached earlier on. And if I go back to some of the questions that we've looked at, I believe it's this question right here, right? So it's pretty much this exact same question right here. So I'm not going to solve this one over here. We know the x value here is going to be x equals to 4. Okay, and then for part B, I guess we need to go ahead and write the first 5 terms for this arithmetic sequence here. So if I just go back to this list here, we know that the x value is going to be 4, right? So this is going to be 4 plus 1. So my first term is going to be 5. And then I have 4 plus 5, which is going to be 9. And then I have a 4 here, so 4 times 3 is 12 plus 1, which is going to be 13. Okay, so those are my first 3 terms. My first 3 terms are 5, 9, 13. And from here, it should be pretty easy to identify that you're just adding by 4 each time. So now we have 17 and 21 to finish this arithmetic sequence there. Okay, that concludes this homework video guide.